Import the system module to access system-specific parameters and functions. Define a function prim_mst that takes a parameter graph, which is expected to be an adjacency matrix representing a weighted graph. V is set to number of vertices in the graph by measuring the length of the graph list. Initialize a list selected of size v with all values set to false. This will track which vertices are included in the minimum spanning tree. Mark the first vertex as selected, starting the MST from this vertex. Initializes an empty list edges to store the edges that will be part of the MST. Loop v-1 times as an MST for a graph with v vertices that has v-1 edges. Initialize minimum weight to the maximum possible integer value x, y to 0. This will keep track of the minimum edge found in the current iteration. Iterate through all vertices u. The inner loop will only consider vertices that are already included in the MST. For each selected vertices u, it checks all vertices v. It only considers vertices not yet selected and that have a connecting edge to u. If the weight of the edges graph of u of v is less than the current minimum weight, it updates minimum weight and records the vertices x and y corresponding to the edge. Once the minimum edge is found, it appends the tuple x, y, weight to the edges list. Marks vertex y as selected, including it in the MST. Print the header for the output of the edges and their weights. Loops through the edges list and prints each edge with its corresponding weight. Define a weighted undirected graph as an adjacency matrix where the value 0 indicates no direct connection between vertices. Calls the prim_mst function with the defined graph to compute and print its minimum spanning tree.